Dear all, in this video we will discuss about the definition of remote sensing, workflow of remote sensing and GIS process, and components of remote sensing. Before starting the video, I would like to notice you to watch the video minutely for better understanding, so that at the end of this video you will be able to answer all the quiz questions correctly. The link of the quiz form has been given in the description drop down menu. Thanks to all for subscribe the channel and watching other videos in this channel. Please subscribe the channel if yet not subscribed. Share it to the concerned learner groups. I will eagerly wait for your comments. Don't forget to put a like in this channel. Definition of remote sensing. Remotely sensed is remote sensing. If you are reading this topic, now you are doing remote sensing. In fact, the process of acquiring any information from the object without touching is remote sensing. Following are some scientific definition of remote sensing. According to India's national remote sensing agencies, remote sensing is the technique of deriving information about objects on the surface of the earth without physically coming into contact with them. According to John R. Johnson, University of South Carolina, remote sensing is the non-contact recording of information from the ultraviolet, visible, infrared and microwave region of the electromagnetic spectrum by means of instruments such as cameras, sensor, laser, linear arrays and or area arrays located on platform such as aircraft or spacecraft, and the analysis of acquiring information by means of visual and digital image processing. Concept of remote sensing and GIS workflow. There are 7 elements on the basis of which remote sensing and GIS technique works. They are categorized as follows: source of energy for illumination, source energy interaction with the atmosphere, interaction with the target, interaction with the atmosphere again, recording of energy by sensor, transmission, reception and processing, and interpretation, analysis and application. Here is the diagram of workflow in remote sensing and GIS. Here, 1 is the source of energy for illumination, 2 source energy interaction with the atmosphere, 3 interaction with the target, 4 interaction with the atmosphere again, 5 recording of energy by sensor. 6. Transmission, reception and processing. 7. Interpretation and analysis and uses. Source of energy for illumination. The most important and primary requirements for any remote sensing process is to have an energy source. The source of energy which illuminates for provides electromagnetic energy to the target of interest. In most of cases, the source of energy is the sun. This remote sensing method is known as passive remote sensing. In some cases, remote sensing method provide their own source of electromagnetic radiation to illuminate the target. The process is known as active remote sensing. Radar is the one example of active remote sensing. To better understanding the fact, we have to acquire the minimum knowledge about the following concept. Concept of energy, electromagnetic radiation. To know the relationship among the energy wavelength and frequency, we have to know the two important models. One is wave model of energy and second is particle model of energy. Concept of energy. The ability to do work is energy. It often transfers one place to another and one body to others. The process of transfer of energy are radiation, conduction and convection. The processes of energy transfer without any medium is known as radiation. The solar energy process through the vacuum space to the earth in the process of radiation in the form of electromagnetic radiation. The process of energy transfer from one molecule or atom to another just beside it is known as conduction. A metal body is heated by a hot burner is the process of conduction. The energy of a body transfer from one place to another by moving the body itself is known as conduction. The process of heating air in atmosphere through rising of warmer air from the ground and falling of cool air to the ground is an example of it. From the three processes, the first is most important for the remote sensing process. Electromagnetic radiation. The solar energy products the electromagnetic radiation. Electromagnetic radiation refers to the wave of the electromagnetic field generated from the sun, propagating through the space, carrying electromagnetic radiant energy. It includes radio wave, microwave, infrared, visible light, ultraviolet, X-rays and gamma rays. Different energy model explains the process of propagation of EMR through space and interacts with other matter. The wave model and particle model are remarkable in this context. In spite of these, to know the relationship among the energy, wavelength and frequency, we have to know the two important energy model. Wave model of energy. James Clerk Maxwell in 1860s introduced the concept of wave model. As per the model, electromagnetic waves travel in a vacuum at the speed of light, which is 3 into 10 to the power 8 meter per second, or 1,86,000 miles per second. Electromagnetic radiation consists of electromagnetic waves and in two fluctuating fields, which are electric and magnetic fields. These two fields are right angle to each other and both are perpendicular to their propagation direction. Both have the same amplitudes at the same time. It can be transmitted through the vacuum. Electromagnetic radiation is generated whenever the electrical charges are accelerated. The wavelength and the frequencies are the two important characteristics of this electromagnetic radiation. We have to understand clearly these two properties in this context. Wavelength. Wavelength is the length or distance of a complete wave cycle. It can be measured by the linear distance in between two successive wave peaks. It depends upon the length of time that the charged particle is accelerated. Greek letter lambda is used to represent the wavelength. The unit of wavelength is meter or factors of meters such as millimeters, micrometer, nanometers and angstrom. The number of cycles of a wave passing in a fixed point per unit time is called the frequency of a wave. The Greek letter nu, that is small v, is used to represent it. The unit of frequency is hertz. It is equivalent to 1 cycle per second. The multiplication values of hertz are kilohertz, megahertz and gigahertz. The relationship between the wavelength and frequency of electromagnetic radiation is inversely proportional. Thus, we can conclude that longer wavelength is related to the shorter frequency and vice versa. It is derived from the formula C equal to lambda nu. So, lambda is equal to C by nu, where C is equal to velocity of light, lambda equal to wavelength and nu is equal to frequency. Particle model of energy. From this model, electromagnetic energy may also be described in terms of joules and electrons volts. The rate of transfer of energy from one place to another is termed as flux of energy, which is measured by watts. The amount of energy generalized by Planck's general equation as Q equal to h nu, where Q is equal to energy of a quantum measured by joules, h equal to Planck's constant, which is 6.6260 into 10 to the power minus 34 joule. V is equal to frequency of radiation. Relationship among the energy, wavelength and frequency from two models. From the particle models, Q equal to hv or h nu. From wave model, lambda is equal to c by v, multiplying h with cv without changing its wave, its values. Lambda is equal to hc by hv. So lambda is equal to hc divided by q, because we know from the equation 1 q equal to hv, then q equal to hc by lambda. Thus we can say from the equation the energy of a quantum is inversely proportional to its wavelength. As the wavelength is inversely proportional to the frequency, so energy is proportionate to the frequency. Q is equal to 1 by lambda is equal to V. Electromagnetic spectrum. The electromagnetic spectrum is the wide range distribution of frequencies of electromagnetic radiation and their respective wavelengths and photon energies. In this entire electromagnetic spectrum, from the lowest to highest frequency or longest to shortest wavelength, includes all radio waves, infrared radiation, visible light, ultraviolet radiation, X-ray and gamma rays. Nearly all frequencies and wavelengths of electromagnetic radiation can be used for spectroscopy. In remote sensing, visible and infrared use as optical remote sensing or passive remote sensing, and microwave used for active remote sensing purpose. Here a clear picture of electromagnetic spectrum. In this side, in left side, higher frequency, higher energy, shorter wavelength. In right side, lower frequency, lower energy and lower frequency, lower energy and longer wavelength. And here also the visible light, which starts from 0.4 mu m to 0.7 mu m. Workflow in remote sensing and GIS for second case. Source of energy interaction with atmosphere. The energy propagates from the source through the atmosphere to the target. It interacts with the atmosphere. The solar energy in the form of electromagnetic radiation first propagates through the vacuum of space almost in the speed of light. After that, it penetrates the Earth's atmosphere. The speed, wavelength, intensity and spectral distribution of EM are affected by the process of absorption, scattering, refraction and reflection in the atmosphere. Absorption, scattering, refraction and reflection. Absorption, the process by which the radiant energy absorbed and converted to other forms of energy is called absorption. The process may take place in the atmosphere and also at the target or surface of the earth. In the atmosphere, ozone, carbon dioxide and water vapor are the most absorbing elements. The atmospheric elements absorb a very specific region of the electromagnetic spectrum. The region of the electromagnetic spectrum which are not mostly influenced by atmospheric absorption are known as atmospheric window. I repeat it, the region of the electromagnetic spectrum which are not mostly influenced by the atmospheric absorption are known as atmospheric windows. The atmospheric windows are very useful to the remote sensing process. The region of the visible light, mid infrared, far infrared and all the higher wavelength region of electromagnetic spectrum are almost opaque to electromagnetic radiation. Here is the atmospheric window. The view of atmospheric windows are represented by the green arrow sign, and you will see the atmospheric window. The chart atmospheric transmittance represent here. In the part of visible light, near infrared, mid infrared, atmospheric windows are present. The absorption and interaction mostly occur at the part of shorter wavelength region where harmful cosmic rays and ultraviolet rays almost destroy. We, the all habitat of the earth, are fortunate for it. The scattering. It is the phenomenon in which radiation energy gets diverted from its straight path on striking the atmospheric particles. It influenced by the wavelength of radiation and the diameter of the particles. The process is subdivided into two. One is selective and another is non-selective. The selective scattering is three types. There Raylight scattering, mixed scattering and Raman scattering. Raylight scattering takes place where the effective diameter of particle is much times smaller than the wavelength of radiation. In the upper atmosphere greater than 4.5 kilometer height, effective diameter of nitrogen and oxygen molecules is very smaller, that is less than 0.1 times than the wavelength of incident radiation. The shorter wavelength scattered more than a larger wavelength. That is why, due to the blue light scattering, we see the same color of the upper atmosphere. In upper atmosphere, we see the Rayleigh scattering, and in lower atmosphere, we see the Mie scattering. Below the height of 4.5 kilometer in the atmosphere, the effective diameter of particles is almost equal to the wavelength of radiation. Here Mie scattering takes place. Here the effective diameter of atmospheric particles is less equal or greater than the length of incident radiation. Raman scattering takes place. The process depends upon the elastic collision of the particles. In non-selective scattering, effective diameter of atmospheric particles is very larger, 10 times than the wavelength of incident radiation. In the cloud forming particles such as water droplets and ice crystals, all the region of the visible light in electromagnetic spectrum scattered and produce the white light. Refraction. The slight changes of direction of light when it passes from one medium to another is known as refraction. It depends upon the densities of different mediums and speed of light. The optical density of a substance is measured by the refraction index. We know the speed of light in a vacuum. If we know the speed of light in a medium, then we calculate the refraction index of that medium by the formula n equal to c by cn. Cn is the speed of light in the medium n. C is the speed of light in the vacuum, that is 3 into 10 to the power 8 meter per second, and n is the refraction index of this medium. Here the incident rays, light bent is its path, that is refraction, angle of incident I, angle of refraction R. As the speed of light, the maximum in a vacuum, show the value of refraction index n always be greater than 1. The refraction error in the image can be removed by Snell's law. It is n1 sin theta 1 is equal to n2 sin theta 2, where n1 is equal to refraction index in medium 1, n2 is equal to refraction index in medium 2. Sin theta 1 is the angle between the ray and line of normal in medium 1, and sin theta 2 is equal to angle between the ray and line of normal in medium 2. Here the reflection, it is the process of sending back of or bounce off the light ray from the top of the surface and of an object. In the atmosphere, cloud is the most important reflector. Ice, water bodies, soil and vegetation are also the important reflectors on the surface of the earth. It is very useful to in remote sensing rather than scattering, as the direction of reflection is predictable. From the smooth surface, the reflection is specular, and in the rough surface it is diffused in type.